Hello everyone. The topic of my presentation is post-fire mechanical property of steel S900MC. The paper was prepared according to the thesis work of Zamenu, and the co-author of this paper include our doctor candidate Saani Shakil and Professor Jari Puttonen. I'm Wei Lu, and I'm going to present the paper on behalf of them. The content of my presentation include background and objectives and some detail about testing method and the result on mechanical property after fire exposure using two cooling method, and then comparison of result between two cooling method and between this study and literature study, and finally the conclusions. For post-fire use of steel member, current design codes include no recommendation for post-fire mechanical property or simple recommendation based on mild steels, and no recommendation available for high-strength steel. For that reason, available literature study these properties based on steel grade ranging from mild steel to high-strength steel using different manufacture method, and the specimen was prepared from steel plate, tubular section, and the cooling method during the test include furnace cooling, air cooling, water cooling. So with this background, the objective of this research is to study post-fire mechanical property of S900MC by using both furnace and air cooling method. The specimen was in flat shape and was cut from a steel plate with a thickness of 3 mm. The specimen was firstly heated inside the furnace with a heating rate of 10 degrees per minute to some pre-selected temperatures, and after that the specimen was kept inside furnace at selected temperature for 12 minutes, and then the specimen was cooled inside the furnace gradually to room temperature or immediately removed from furnace to air after the heating. And then in a couple of days, all the specimens were tested on universal tensile test machine, and the gauge length used was 25 mm. And here the retention factors for mechanical properties for furnace cooling method and air cooling method, as can be seen here. So basically the retention factor for modulus of elasticity reduced at the cooling temperature of 750. So the retention factor is about 95% for furnace cooling and about 90 to 80% for air cooling. And the retention factors for yield strength reduce at about 500 degrees, and the retention factor varied from 90% to 25% when the cooling temperature are between 500 and 900, and the ultimate tensile stress reduces at about 400 degrees when the cooling temperature is about 400 degrees. And for the furnace cooling, the retention factor is about 95% to 35% when the cooling temperature were between 400 and 900 degrees. But for the air cooling, the retention factor for the strength is about the same, but only when the cooling start above 750, there's some the retention factor will about 10% rise. And this slide basically shows the stress strain curves at some selected cooling temperature. Like right hand side shows at 700 degree, middle is 750 degree, and the right one was about 900 degree. So it can be seen that ductility for both furnace cooling and air cooling increased when steel were cooled from 20 degree to 900 degree. And when compare both cooling methods, can be seen when the steel were cooled from 700 below. So similar retention was observed in both cooling conditions between or at 750 and 900 degree. Basically, air cooling produce higher retention on strength, but decrease ductility more than furnace cooling did. And at 750, retention factors are irregular in air cooling, so it can be seen from the stress strain curve in the middle. So when the modulus of elasticity is compared between this study and literature study, it can be seen that basically the from 500 degree, the oldest selected steel grade retained at least 95% of modulus of elasticity, but from there, the retention factor reduced from linearly with the increase of cooling temperature, and the difference among different steel grade can be up to 20%. So the reason basically is due to the elastic modulus is affected by creep above 400 degree, and also the phase transformation at critical temperature between 723 to 910. And this slide shows the comparison result on effective yield strength. So basically it can be seen here that when the steel cooled from 900 below, so the retention is about 90% of the room temperature value. But after that, the retention factor decreased linearly with the increase of cooling temperature, and the minimum value can be like 30% of the room temperature value. So the reason is because the effective yield strength is affected by grain size, grain boundary, solid solution, strain hardening, and hardening due to the formation of martensite. So these factors actually depending on working condition, working temperature and cooling method during the manufacture process. And this slide basically shows the comparison result on ultimate tensile stress between different studies. So it can be seen that from 400, starting from 400, the cooling temperature, so all the steel grade retained at least 10% of the strength. And after that, the retention factor reduced linearly with the increase of cooling temperature. And the difference basically varied from steel to steel. So for the S900 steel grade, so the retention was the lowest. And for other steel, the difference can be 10 to 20% at different temperatures. So basically the conclusion from this study is for S900MC, so elastic modulus can be fully retained when the steel cooled from 700 below. But then if when the cooling temperature is at 900, then the steel retained about 80% of its original value. For the strength, so below 500 degree when the cooling start, so then the retained strength is at least 90%, but after that the strength retention is only 20 to 40%. And for the studied steel, the air-cooled retained higher strength but lower ductility compared to the furnace-cooled steel from 700 degree cooling temperature. And for all the studied high-strength steel, so the scatter of the retention factor is between 700 degree and 900 degree. It seems that more study on retention factor of mechanical properties and their effect on member reusability are necessary. So let's bring my last slide, the acknowledgement, and also thank you for your attention.